Hi class, today we're doing section 2.3, Derivatives of Natural Logarithmic Functions. The objectives in this section are to find the derivative of functions that include natural logarithms and to be able to solve applied problems using natural logarithmic functions and their derivatives. So let's go ahead and get started now. The derivative of natural log of x is 1 over x. That is, if anytime we need to find the derivative of the natural log of this value, it's going to be 1 over x. Now that's true for only a restricted domain on x, because the natural log has a restricted domain and the argument must be positive. When our argument is x, then the x has to be positive as well. For our first video example, it says to differentiate the following functions. So we're given y is equal to 5 ln of x. Notice that the 5 is a constant, and so we can apply the constant multiplier rule. I'm just going to take the derivative of ln of x. So we're going to write dy dx, and we're going to leave the constant multiplier there, and the derivative of ln of x is 1 over x. So let's simplify that to be 5 over x. For our second example, part B, notice that you have x cubed times ln of x. So we do have the product rule going on over here. So I wrote the product rule on the side. We're going to find the derivative. So we write dy dx. That derivative is our first function, x cubed, times the derivative of ln of x. That derivative is 1 over x. And then we're going to add ln of x times the derivative of x cubed, which would be 3x squared. And then we have to get the derivative of the 4x, so that would just be plus 4. Let's simplify this a little bit. X cubed times 1 over x becomes x squared. And in this one, we're going to pull our coefficient and our variables before the ln of x, and then we're going to add the 4 at the end. Alright, let's get some more practice. Part C of this example continues on with differentiating, so we're going to find dy dx. You could also write it y prime, so let's just do that, because that means the same thing. And then we're going to find the derivative of this quotient. Notice I put the quotient rule over here, so we're going to first pull from the denominator, the x squared. We're going to multiply that by the derivative of the numerator. The derivative of ln of x is 1 over x. And then we're going to subtract the numerator, multiply that by the derivative of the denominator. It should be 2x. And then we're going to write that over the denominator, the whole thing squared. So we want to simplify this. X squared times 1 over x is just x. And then we want to bring out the coefficient and the variable. So we're going to say minus 2x. That always goes in the front. And then any functions that get multiplied go in the back. And then x squared squared is x to the 4th. You should notice that there's an x here, and an x in the denominator. So let's factor those x's out. I get an x times 1 minus 2 ln of x all over x to the 4th. That can reduce. So the x here and the power there. And so I end up with 1 minus 2 ln of x all over x to the 3rd power. So there you go. You want to simplify it as much as possible. This page just tells us what happens when we take the derivative of a natural log that has a function as its argument. The answer would be 1 over that function, and by the definition of the chain rule, then we would have to multiply by the derivative of that function. In other words, it's f prime over f. Let's see what that looks like. If we're asked to differentiate, we should take a look at the equations we're doing and try to decide if we're doing product rule or chain rule or any other rule going on. And we have to see which one's our inner function and our outer function. This 5x is our inner function inside our natural log function. So if we're asked to differentiate, let's say dy dx, that would be 1 over this function because that's the derivative of natural log. And then we're going to multiply that by the derivative of 5x. The derivative of 5x is just 5. So you end up with 5 over 5x. And that simplifies to 1 over x. You've simplified it, so now that's our final answer. Let's do the next one. We have our function, so we want to find the derivative of the function dy dx. We're going to say the natural log derivative is 1 over the part that's inside the natural log. And we're going to multiply that by the derivative of this part. So that would be 3 times 2x to the power of 1 plus 4 is just 0. Let's rewrite that. That becomes 6x over 3x squared plus 4. And there's nothing else I can do to simplify this, so that's my final answer. Notice for this next question, we're asked to find the derivative of ln of 5x. So that we're actually going to be doing the chain rule twice. So the first thing is that this whole part in the parentheses is my first argument of this first ln. So if I'm asked to find the derivative f prime, I'm going to find the derivative of natural log, that's 1 over the argument. So that's going to be 1 over natural log of 5x. So now doing the chain rule, we're going to find the derivative of the inside. And so that's the derivative of ln of 5x. This is the argument of the inner ln. And so the derivative of the natural log is 1 over the argument. And then now we have to do the derivative of this argument. So the derivative of 5x is 5. Now we can reduce the 5. So 5 divided by 5 goes away. There's nothing else I can reduce. So if I want to rewrite it, I would get f prime of x is equal to 1 in my numerator. Pull out my variables in the front, and then I have ln of 5x. So there's my derivative. Alright, now let's move on to the last question. We have f of x is natural log of this quotient. So we're going to find the natural log of this quotient. So the argument is this part, x to the 5th minus 2 over x. So to find f prime, we're going to put 1 over that. And then we're going to chain rule to find the derivative of that argument. Now that argument is a quotient, so we have to use the quotient rule. It's always a good idea to reference our rules, so I put the quotient rule right here. That's going to give me the denominator times the derivative of the numerator, and the derivative of the minus 2 is nothing. And then we're going to subtract the numerator times the derivative of the denominator. The derivative of x is 1. And then we're going to put this all over x squared. Now let's rewrite this. That's going to give me f prime of x. 1 over a fraction just gives me the reciprocal of that fraction. And then you want to multiply this part out. That would give me 5x to the 5th minus x to the 5th plus 2 all over x squared. Now before I multiply this out, I should see that there's an x here and an x squared there. I don't think there's anything else I can simplify at the moment, so I'm just going to rewrite this. 5x to the 5th minus x to the 5th is 4x to the 5th plus 2. My denominator will be x times x to the 5th minus 2. And remember that for each numerator or denominator, you need to keep parentheses around it. So this would be x to the 5th minus 2, all in parentheses, times the x, which we pull out to the front. Single variables get pulled out to the front before binomials. And there's nothing else I can do to simplify this, so this is my derivative. For this next question, it tells us that in a psychological experiment, students were shown a set of nonsense syllables, such as poc, riz, and dec, and so on, and asked to recall them every minute thereafter. The percentage R of t, who retained the syllables after t minutes, was found to be given by the logarithmic learning model. R of t is equal to 80 minus 27 natural log of t, for values of t between 1 and 15. The question asks, what percentage of students retain the syllables after 1 minute? If it's asking that, then we're just plugging 1 into our value for t into R of t. So let's plug that in. You get 80 minus 27 natural log of 1. Now you can use your calculators to do this, but you should also know that natural log of 1 is 0. So this is going to become 0. And so 80 minus 0 is going to give us 80. And we should put a label on this because it's an answer to a word problem. So what is a label? Is it how many syllables? How many students? How many minutes? What is this? And when we look at the question, it says what percentage of students retained? And we're finding the percentage of students. So this would be 80% of students retain the syllables after 1 minute. And then part B asks us to find R prime of 2. So first we need to find R prime of t. And trying to find the derivative of that, the derivative of 80 is 0. And then we're going to do the constant multiplier. So you have minus 27. And then the derivative of natural log of t is 1 over t. And so you end up with negative 27 over t. Now if we're asked to find R prime of 2, you're just going to plug 2 into that. So you get negative 27 over 2. That gives us negative 13.5. And what is this? Well, it means that the change in percentage per minute will be negative 13%. So this is going to go down 13.5% per minute. And the rate of change at 2 minutes in is that each minute there'll be 13.5% less students who remember the syllables. For our last example, the phone Stare device is released into a test market of 1 million potential customers. Initially, 500,000 free units are distributed in the market with the intention of stimulating sales. After that, the number of weeks needed for the total number of units distributed or sold to reach n units is given by this function. T of n is equal to 28 times natural log of 500,000 divided by 1 million minus n, where n is a number between 500,000 and 1 million. So we have 3 questions. First, we want to find out what t of 900,000 is. So plugging in 900,000 as our variable, you do want to make sure that when you're finding natural log of this, you might want to put parentheses around this whole quotient to make sure the whole thing stays in that natural log. Go ahead and ask your calculator. And if you wanted to reduce this part in pink, you could. And you would get 28 natural log of 5. And then 28 times natural log of 5 gives you 45.064. And what does this mean? It says to interpret the meaning. It means that the number of weeks needed for the total number of units distributed or sold is this number. So it would take 45 weeks for 900,000 units to be sold or distributed. For part B, it's asking us to find t prime of 900,000. So first we want to find t prime of n. In order to do that, we are going to say 28 times the derivative of the quotient, which we know is going to be the reciprocal of the quotient. And then we're going to multiply by the chain rule, and that would be the denominator times the derivative of the constant minus the numerator times the derivative of the denominator, which would be 0 minus 1 all over that denominator squared. Well, the 0 times this will go away, and then we just need to multiply that out. We do have a 1 million minus n here in this numerator, and we have a 1 million minus n to the second power here, so that will cancel out. And then I have a negative times 500,000 times negative 1. The negative 1 and the negative will cancel out, and I have 500,000 divided by 500,000, and so that will cancel out as well. So I just have 28 over that. So the derivative is 28 over 1 million minus n. Or what is t prime of 900,000? Well, that's going to be 28 over 1 million minus 900,000, would just be 100,000. My calculator says 2.8 times e to the negative 4, which means I would go 0.00028. This is in the 4th decimal place after the decimal point. And so that is the rate at which we're changing. What are the units for this? It's going to be weeks per unit. So you're going to be changing this many weeks per unit sold. That's because t measures weeks, and then n measures units, and this is dt over dn, so the change in weeks over the change in units. This is the equivalent of selling a new unit every 2.8 minutes. That's pretty frequent, isn't it? For part C, it asks us how many units have been distributed or sold after 20 weeks. Now 20 weeks is my value of t. And then it says find out n. And so to do this, we need to set our equation equal to 20 and then solve for n. So I would have 20 is equal to 28 ln of 500,000 over 1 million minus n. Before I can rewrite it, I want to divide both sides by 28 and reduce. So that would give me, well, let's just write 20 over 28 would give me natural log of this argument. And 20 over 28 reduces to 5 over 7. Now I can take this and rewrite it. That would be the argument is equal to e to the 5 over 7 power. Now let's simplify this, multiplying both sides by that denominator. And then you want to distribute that out. And then I'm going to move the variable over to this side and the numbers over to that side. And then I'm going to divide everything by the e to the 5/7. And then using my calculator to simplify the right-hand side, I get n is equal to 755,229. N stands for number of units. So this would be how many units are sold after 20 weeks. So there's a lot of stuff to practice in this section. It's very short, but you want to practice doing the derivative of natural log, combined with the quotient rule, combined with the product rule, combined with the chain rule, and also understanding what that means when you're using it in context of a word problem. Thank you very much and have a good day.